Hello, and welcome back to the stream. I'm so sorry that it has been just a little bit. Um, it's been, yeah, it's been a little bit, and I'm glad to be back here. Let me just make sure that we are streaming correctly. I am not hearing any sound, so let me verify that that is working. So that's outputting. All right, let's see if that worked here. Let's try that again. There we go. Okay. All right. Well, welcome to the stream. Really appreciate you being here. If you're watching, and if you're watching later on, that's fine too. Today, I wanted to talk a little bit about the last couple of weeks because it's been 2 weeks since I've streamed. Excuse me. And I wanted to talk a little bit about the big changes that have happened so far. So first, let me show you where we're at with the game, though, so that you can see it. So I'm just going to go ahead and run it. And should pop up in just a second here. What we've got right now is I've got a little tile map that I pulled off of itch.io, got a little sprite I pulled off itch.io. The boxes you see here are collision boxes, and then that little guy is doing pathfinding. You can see there's, obviously some bugs here. But if you paid attention to that, what you've seen, and let me do that again so you can see it, is that this little guy is going from point A to point B, but he's avoiding the collision boxes when possible, and trying to find the best route between point A and point B. So I have some pathfinding that's been done. I'm using the A-star pathfinding algorithm with a particular library. I did not try to code that myself. I did try to code one myself, and then realized that, hey, I don't need to spend all my time here. So that's where we're at with the game so far. What's changed? The biggest change that we have is that before we were working on this thing, we were working with Bevy and Godot, and we were looking at Bevy as a basically the logic engine and the game logic, and then Godot as this presentation layer, because Godot you can package things up nicely and ship it. And the reason I went for that direction in the first place is because doing UI work visually would be probably a little bit more helpful. I was worried about shipping out to platforms, which is something weird to be worried about, a year or two before you even ship. But I was thinking, hey, I could take advantage of all this Godot stuff, and then use the language and use an ECS system that I really enjoy. Chose not to go that direction for a few reasons. One is that working with any kind of assets in Bevy was kind of a nightmare because of the mismatch between Godot and Bevy. You really have to use all the assets from Godot's side, or make those assets available and then interact with them directly as nodes in from the Bevy side, which just was not going to work, right? And it was a little inconvenient, especially as I looked into things like the tiled map editor for collisions. One of the biggest issues was trying, and one of the things that drove me away was that demo you saw was a tile map with collisions on it. In order for Bevy to understand collisions, I would either have to, or what I tried first was, let me load a tiled map into Bevy with all the collision information, and load the same exact map into Godot, and then be able to interact with it that way. And that just did not function well. Again, the assets loading became an issue. The translation between the two became an issue. The second method I tried was, well, let's just have Godot. We'll use Godot's tile map layers and its collision information, and just pass that down into pass that down into Bevy. But then we're making a lot of this hard coupling between the Bevy layer and the Godot layer. I'm having to do a lot of introspection as to like, okay, inspecting these nodes, getting the tile map information, making sure that Bevy understands that information. Because I would love to do a lot of the simulation on separate threads, but a lot of those threads require information about the map and the players in the map. And so I'd have to do this entire synchronization layer, and it just started to become it became a mess. And what I've learned in my years as a software engineer and even in commercial land is that if you are trying, you're trying to go a certain direction, and everything you face in that direction is a problem, and it just becomes like this giant uphill battle, it might be time to rethink your direction. Not in all cases, because in some cases you're doing something entirely innovative and you should be innovating. And so you are going to run into hard problems. But in this particular case, I wasn't doing anything really innovative or needed to do anything innovative. And so I was running into these hard problems and these issues when I definitely did not need to. So I, about a week ago, kind of threw up my hands and said, you know what? I need to make a choice, either Godot or Bevy. And I really liked Bevy. I still really like Bevy. I like the Rust aspects of it. And for a simulation, and especially a roguelike style simulation, ECS is really kind of the way to go for what I need it to do. And it's a system that I can understand and work with. So I decided to ditch Godot, and I started moving so much faster. Instead of spending a week and a half getting that tile map figured out and trying to figure out collision boxes in the world and then do pathfinding, I was able to throw what you saw together, that whole demo. You know, I was able to throw that together, this thing here, in like a couple of days. Um, and that was like coming from scratch of like dealing with tiled, learning the Bevy North Star pathfinding algorithm library, the whole thing. But I was able to do that much faster and much easier than spending a week and a half with Godot and Bevy. So unfortunately, like I would love to say that those would have worked out, and they still might work out for certain games. But right now, I don't know that that connection is mature enough, or in this particular case, worth it to go that direction. If you still wanted to use Godot and adopt an ECS system, there are better options. There's a lot of C sharp ECS systems like Arch, and others, which would do a much better job of integrating with Godot at the C sharp level and using ECS that aren't going to run into the same problems Godot does. One sec. So, with that being said, we are saying goodbye to Godot. Um, I think it's an amazing engine. I think it's got a lot of potential. I think it is going to make and enable a lot of indie developers and short time or small developers to do a lot of good work without having to pay a lot of licensing fees or be beholden to bigger companies. So I think it's really important. But we are not going that direction. We are instead going with Bevy. So let's look at the project that we have, just to give you a brief refresher on a little bit of how Bevy works and how we're kind of structuring this project. Hopefully you can see this okay. I did blow it up. I know that the left sidebar is going to be a little bit harder to see, but as you can see, we are. Let me get this close all and just open up main. Um, we have a few things in here. I've had to use the avian physics plugin. This is what allows me to use those collision boxes from the tiled map. I'm using the Bevy ECS tiled crate, which allows me to import tiled maps and then generate entities and collision boxes and all sorts of different things within that tiled system. And then I'm using the Bevy North Star crate. And the North Star crate, I'll try to remember to put these in show notes. I probably won't. I'll try. But the Bevy North Star crate is a pathfinding crate that works really well with Bevy. And in particular, we're using the A star algorithm, which is really great in a grid system. The way I have structured the rest of the project is setting these things up as setting my modules up as plugins. So we have the world plugin, we have the NPC plugin, and then I have a demo plugin, which is where I have the actual demo information. And then obviously just a quick camera setup for that. We're going to start in the world today. And then I'm just going to show let me show you some portions here. And then we're going to talk about the Bevy messages for the next little bit. So in the world, if we go into mod, you can see this is the definition for the plugin. I try to keep my mod files small. I try to keep a lot of definition or a lot of documentation in those files and not a lot of code. But it's a perfect place for us to declare the plugins. As you can see, I have a type that I have to register called walkable. This type gets exported out to tiled. So I have a bunch of tiled types that I can export. One of them is my particular type for walkable. And what that allows me to do is in the tiled editor, which I'm not going to show today, but it allows me in the tiled editor to specify what tiles are considered walkable, so that we can mark those as passable tiles for the North Star algorithm. And so what that means is that I don't have to go into every single map and then draw out all the areas that they can move. I can basically say, hey, this grass tile type should be walkable. Obviously, if there's no path to it, or if it's surrounded by colliders, that's not going to work. But we have a way to handle that. But for generally, it should always be a walkable tile. And that's really helpful. And then we have a startup system for setting up the tile map. And then we have an observer, which is building the North Star grid from the tile, which is fine. So let's dive into these two really quickly, and then we'll get into the messages and why we're going that direction. So setup tile map is very, very simple. We're using the asset server to load in a tile map TMX file. And that relies on a bunch of other assets. Now, I have not worked on any kind of asset packing yet. I am not shipping those inside the binary. We'll play around with those later. Once I have that handle to a tiled map asset, what I can do is then I can spawn the tiled map, and then I just center the tile map on the I center the tile map. If I'm not mistaken, this is the center of the bottom left tile, right? So it is the center of the bottom left tile. So the bottom left tile is now in the center. I can put it in the bottom left. Basically, it just lets me put the anchor of this tile map wherever I wanted to. That's all this one is. So if you go back to mod, this is the big one. This is the observer. In Bevy, you have events that can fire at any time, and observers, which when those events fire, will immediately execute. And you don't want necessarily a ton of observers, or you don't want, you have to be very careful with the observer system about why and when you're using it. In this particular case, where we want to immediately build the North Star grid once that map is available so that other systems have it, an observer makes a lot of sense, right? Because the setup tile map, once this is loaded, this asset server, the implementation of the asset server for tiled map asset will fire the event saying, hey, by the way, my tiled map is loaded and ready to go. So now what we can do is we can act on that. And the first thing we do is we have to build a North Star ACE grid in order to feed to the algorithm. So what has to happen here is that we have our tiled map, we have our tiled information, we have tiles that are marked walkable, but we have to put those in a grid, or we have to represent the entire map as a grid of connected points in order for the A star algorithm and North Star to work. Okay, so again, we have the map entity. This is the actual tiled map. we pull it from storage, we get the tiled map, we build a North Star grid with the height and width that is the full map. This is extremely important. And then we set the chunk size, and the chunk size is basically the size of each square, right? So this is a 16 by 16 square. So we have the full height and width of the tiled map. Each square should be 16 by 16, and we're saying that all of the grids, all of the points in that will be defaulting to impassable, right? So we're saying everything in this grid, unless we specifically say that you can use this in your navigation, we're going to say that this is not passable. Next, we pop into the grid and ordinal system. This is just the movement in 8 directions, and not just 4. So diagonals work. And we're basically saying, hey, we can move one part, and this is what we're doing. So now the big thing, and this is not terribly difficult, we have to go through our tiled map, which we just loaded, and basically match the tile coordinates to the North Star grid that we've just created, and examine the tiled coordinate, or the tiled grid at that coordinate, in order to determine whether or not this is marked as a passable location for North Star, right? So the first thing we have to do, is we have to build a hash set. Um, and a hash set is basically just a hash map, with no value. This is a really convenient data structure for when you want to make sure that you're not repeating a key, but you really don't have any values to put in there. So hash sets are really convenient. They're not bad. Log y or big O wise, they're not the worst for what we need to do. What we do then is we go through each of the tiles, right? Um, inside that map, and we check that entity to see if it has collision. And has collision is basically we could have done this inline, but this was just a lot easier. So we get the tile, we map that tile to see, or we use the map function to get anything if we have any of those tiles in this tiled map tile entity has collision. Now remember that inside tiled, we might have multiple tiles on the same tiled map coordinate because of layering. And so what we have to do is we have to actually iterate through the storage tiles entities, right? In order to the tiles that are there, in order to check that they have collision. And we are going through the actual entity. This is all the entities for that coordinate that is in our system. And then we basically check to see, hey, does this tile data, for this tile entity at this location, right? Does that have collision data? And if it has collision data, add it to the vec. And we know that the truthy value for a vector is whether or not it has any kind of values in it, has any members. And so if there's no members, this is going to evaluate as false, and so we're not going to do anything. If it does have members, what we do is we take a look at that. We get the actual position in the world of that tile, of the tile entity, and we take that position, we insert it into this vector. And this is really important. We need this. So now we have a list of any tile that has any kind of collision information at all. Because since we're moving tile by tile, we want to do it that way so that we're not, we don't need to worry too much about the shapes, just the fact that we can't move it to that tile. Now we iterate through the rest of the tiles, and we check those tiles. We're doing the same kind of thing, but we are checking now to see, okay, if they have a collider, right? If they're in blocked, then we'll ignore this. So if it's not in blocked, if the tile that we're iterating through this time, and we could potentially do this in one iteration loop, iterative loop. Honestly, looking at this, we could probably do this in a single iteration loop instead of iterating through this twice. That's a good note. I was going through so fast through it, I just didn't really care about it. So we'll fix this later. So let me do two single iterative loop. Okay. Anyways, so now what we do is we check to see, okay, does this tile's location exist within our vector, and we won't even need that vector later on. Okay, is it blocked? Okay, now we check to see, is it walkable? Does it have the walkable class on it? Now the cool thing is, if you remember that class that we talked about, this walkable type, because we've exported that type to tiled, when we import the tiled map, it will, when it creates that entity, be able to reflect back to the Bevy types that we've registered and say, oh, hey, yeah, you're telling me that this is a Bevy walkable type that's located in this crate. I know how to do that. So I'm going to look at that and assign that. So now I can say, hey, I can get the walkable. I can get that query out. And if you look up here, the tile query, that's probably why you have to do it in two now that I think about it. The tile, yeah, that's why we have to do it in two, because we're iterating through all the tiles the first time. And then we have created this tile query that is only the tiles that have a walkable, and I'll have to look at that, that have a walkable component on them. So now we're checking, okay, if it is walkable and it's not a grid square with a collider, we're going to say that we need to set this in the nav grid that it is passable. That's it. That's all we do. And once we've set that, we can then go into the movement system. It's not really what I wanted to talk about today, but now I'm wondering if we should go into the movement system. And then I can change the title. Since I don't think we really have anybody watching this at the moment. Let me check one thing. We don't have anybody watching. I might just change the title and move into this particular next system. No, no. Okay. Okay. Hold on one sec. Sorry that I'm not doing that. Okay. All right. So let's just do that. Let's change this to be um to talk more about the nav system and then call that a day. So once we have this North Star grid nav system, right? We have a grid that we can use. It's saved as a resource. Or well, let's see. Where is the grid? Build North Star grid order neighborhood. We spawn the grid as its own entity, so it's not a resource. The reason North Star does this is something you'll have to look into the documentation for. But we just spawn it as an entity so that we can view it in other systems. So let's go into the NPC directory. If you remember, the way I've split up my project is that I split them kind of along massive logical boundaries, and then anything that iterates over a Bevy ECS. So I have the components, I have the resources and the systems. Again, in the mod file, we have the plugin for it. I have an observer, which is how we spawn the NPC. We're not going to dig into that one, but we are going to talk, or the systems. We are going to talk about the walking systems, right? And actually, it might not be here. Might be an AI. Where? No, it's in the demo. That's right, because I threw it in the demo. Okay. So in the demo, right, we have this move system. That's the Pathfinder. Do. Okay. The first thing we have to do in order to make this work is that we build an NPC, right? We have to spawn an NPC with a certain thing. We're not going to dig into that, but we have to give it a position, an agent position, and the agent position is a position on the grid that we've created for North Star. Um, and we have to update this position as we move so that the rest of the thing can figure this out. So we're going to talk about moving the NPC. First, the system that does this has a timer. Okay. Um, and the reason we use this timer is so that we can do this by tick. And the tick we have on this timer is, I believe, I have this set to a second. So basically, all this is saying is like, hey, if the timer is still waiting and it hasn't just ticked, then we just continue on. If we just ticked, then this is the first time after our tick. Um, then we actually go through and do this movement stuff, right? Okay. Um, if you have noticed, I did have AI write the comments for this code. The reason I did that because I didn't want to go back and add these all for everyone who's reading this code. We'll talk about what I use AI for later on. I'm very skeptical of AI overall. I'm very careful about how I use it. I don't believe what it's doing to the environment is something that's worth using a lot of it for. I try to use local models when I can. A lot of things we can talk about that in a different stream. Anyways, so first we want to update our grid position, right? And what we're updating our grid position on is this is the NPC query. So if you look at this NPC query, we have the next position in the pathfinding system. So what happens is in between our system running and this timer running, the North Star timer, or sorry, the North Star system has already ran, and maybe it ran before, and maybe it's done a lot of this pathfinding already. But what it's done is it's attached a component to your entity, which is the next position that you should move to. Right? That's what it attaches to this entity. And the next time it iterates through, that system will look at the agent position and the next position and say, oh, hey, this agent has moved to the next position and they are the same. So now I need to iterate and add and update the next position to point to another to point to another one. So in the background, the Bevy, the North Star system is constantly updating this next position as long as the agent position changes to match. So that's the first thing we do. We update our position on the agent to match what the next position should be. Now, keep in mind, this doesn't actually move our sprite or anything because this is still the position in the North Star grid. This is not the world's grid. So now, what we have to do is we have to relation. Okay. Yeah. We have to then combine and we wrote a little function for this called tile to world, which is just basically converting our tile location that we're getting from that into um, our centered map. This is going to change. This was quick and dirty to get what I needed to do working. So basically, we are translating now between the North Star grid and the world tile map grid locations. Once I do this correctly, I am going to create the map in such a way where I don't have to do this translation. to where it all starts at 0, 0. Same thing for the map, and the map's up in the upper left-hand corner. But for right now, I had to do this little conversion in order to make that work. This transform is this transform is what actually moves the sprite, right? Because once we change the transform on the entity, then it updates the world on the next render cycle and moves that sprite forward. This is where you can throw animation in, all sorts of different things. Then we just log it. That was really helpful as I tried to figure out what the hell was going on. And then we have to remove the next position. I don't know that you absolutely have to do this because I'm pretty sure North Star does the next position system does a check on agent position, next position. But I just went ahead and removed it anyways because that seemed to be the right thing to do. Now, because of these two systems, again, if we look at the plugin that we're doing, we have demo state, we have the timer itself, we have the spawning of the NPC, but then we have the actual moving, and then we can handle failures. This is basically throwing messages out and working with pathfinding failed. Don't need to worry about that today. Not too worried about it. But this is what I worked on, and it did not take me very long to get this up and running with the bare minimum of code. And I think it's really important that it was so much easier is the wrong word, because for some people Godot's side would definitely be easier, but for me it flowed so much better for me to do this all in Bevy, to work in a single system, to work with ECS, to work with Rust, than it does. I'm still worried about if I ever ship this game to something like a Steam Deck with controls, whether or not Bevy is going to be mature enough to handle that. But I have a lot of faith in the community, and if I need to, I will help, and I'll upstream what I need to in order to get this shipped out to the Steam Deck. Again, one of the biggest constraints is that this is still a Steam Deck native game. Like that is the big thing here, is that this is going to be a Steam Deck game. This is not going to be a UI tacked on later on. This is a Steam Deck native game. So thank you for joining us. Again, I am sorry it has been so long since a couple weeks since I've streamed. Really appreciate you if you stopped by the channel. I'm hoping that I can find a good balance between working on this and being something that's different. I'm focusing on the Bevy aspect. I'm focusing on Rust. And I'm not focusing so much on like, hey, watch me build this game and look at this cool game. I'm hoping to teach you aspects of Bevy and Rust as we go through, versus trying to like make you watch me build a game, because I don't find that intriguing personally, and so I don't think I'm going to be a good person for doing that, right? So thank you so